Right. Let's start the class. Good evening, all. Right. I need to do some mixed exercises on what we have done up to now in the theory class. So I will give you some questions. These questions are not in your tutorials. So write down these questions. This may be going into your tutorial exercises, tutorial mixed exercises, or else you can maintain a separate book as well. It's okay if you can maintain a separate book. That would be better, right? So write down this question. These are all new questions, not in the tutes, and you can refer to these questions later as well. Some special questions will be discussed in the night classes, right? So number one, so the first few questions will not be special, just for your practice purposes. What we have done in the immediate previous class, right? Number one, calculate concentration of a solution prepared by mixing 50 grams of calcium carbonate in 50 cubic centimeters of water. 50 cubic centimeters of water. So please revise the question like this. Calculate calcium carbonate concentration of a solution prepared by mixing 50 grams of calcium carbonate in 50 cubic centimeters of water. Within brackets, calcium is 40, carbon is 12, oxygen is 16. Right. So I will do this question for you because you are new to these concentration questions. If you can continue. If you get the answer, you can let me know as well. So continue if you can do this one, but let me explain this one because this is something not familiar. We have discussed this one, but we have not done that much of questions. So we can say the concentration means how much of solute is dissolved in 1 cubic decimeter of solvent. That is the basic idea. The amount of solute is measured in moles. So therefore, concentration is measured in moles per cubic decimeter. One of the popular unit in chemistry, moles per cubic decimeter. So this is the concentration unit. Concentration is also called as molarity. Molarity. This is another name for the concentration, right? Another name for the concentration, molarity. Molarity. Moles per cubic decimeter, the unit also denoted as capital M. It is not encouraged to use this one, this capital M, because like how this is used, moles per cubic decimeter can be that moles per cubic decimeter, that wording or unit can be replaced by capital M, but I am not encouraged to do this one until you go into the equilibrium questions. For chemical calculation questions, you have to use this unit, moles per cubic decimeter. So like for an example, let's say the concentration is 0.2 moles per cubic decimeter for the molarity. You can say this one as, or you can write this one as 0.2 capital M. But for chemical calculation questions, I do not encourage this notation. For equilibrium questions, you can do this one because there are many other calculations, many other complex calculations in equilibrium. So therefore, to save some time, small amount of time, you can use capital M, but you have to be mindful. Capital M is used for moles per cubic decimeter, not for moles per cubic centimeter or moles per cubic meter or any other related unit of the concentration or molarity, right? So this is something that you should know. Concentration is moles per cubic decimeter and molarity is capital M. මම මේක note එකකට දෙන්නම් තියෙන note එකකට සඳුදා sorry ඉරිදා yeah උත්තරය දුන්නා ඒක මම හිතන්නේ හරි ඇති. So these units also need to be unit and this name also need to be remembered, right? So now we can calculate moles of, first let's get, we need to know moles of calcium carbonate in 50 cubic centimeters. So you can say mass divided by molecular mass of calcium carbonate. Mass is 50 grams. Molecular mass or relative molecular mass can be calculated. Calcium is 40, carbon is 12, oxygen is 3. 3 means 16 into 3, that is 4800. So grams per mole. So this is dissolved in 50 cubic centimeters. Yeah, 50 cubic centimeters. So we can say, therefore, concentration of calcium carbonate, concentration of calcium carbonate. So this amount, this moles, is within 50 cubic centimeters, right? Sorry, the moles is 50 grams. Well, sorry, 50 grams. This is the moles. 50 divided by 100. This is the moles. This is within 50 cubic centimeters. How much within? 1000. So this is moles per cubic decimeter. This is just a ratio. So this is the number of moles. This number of moles is within 50. Then how much within 1000? That is the basic idea of the concentration. Concentration means how much of moles is within the 1000 cubic centimeter. So 1 cubic decimeter. 1 cubic decimeter is 1000 cubic centimeter. That is what we have discussed, right? The unit conversion. So this is simply we can say 10 moles per cubic decimeter. 10 cubic 10 moles per cubic decimeter is a like huge concentration comparatively. Very huge concentration. Right. Second question. Density of water is 1 grams per cubic centimeter. Density of water is 1 grams per cubic centimeter. Calculate concentration or molarity of water, assuming 100% purity. Calculate concentration of water assuming 100% purity. Kita hadlan ba? You can try this one. I will explain. You can try. there was a message, this meeting is transcribed. What is transcribed? Transcribe means chemistry. Transcribe means uh, converting spoken language into a text. That is called as transcribe. That's okay. The beginning, okay. I'm totally okay with that. What the other. Density of water is 1 grams per cubic centimeter. So we have been asked about the concentration of water. Concentration of water, assuming 100% purity. 100% purity means like if you take water sample, that is 100% water. That is the idea. So now the density means mass in 1 cubic centimeter. That is the density, right? Oh, mass in unit volume. Density means in the given units, mass in 1 cubic centimeter. Concentration means moles in 1 cubic decimeter. So this is the idea, right? Here for mass, for density, I have used 1 cubic centimeter because that is the given one. Otherwise, you can say in unit volume, right? So there is some kind of relationship between density and the concentration. Density means mass in unit volume, and concentration means moles in unit volume, right? So there is some kind of connection here. When density is given, it can be easily converted into the concentration because density is related to mass, concentration is related to moles. So we can write this one as like this: mass in 1 cubic centimeter of water. That is 1 gram. Simple thing, right? Then I need to convert this one into 1 cubic decimeter. So 1 cubic decimeter is equal to 1000 cubic centimeters. If you can remember, I told you 1 cubic centimeter is equal to 1 milliliter. Then 1 cubic decimeter is equal to 1 liter. So which means 1000 cubic centimeters is equal to 1 cubic decimeter, right? Right. Right. So I can convert this one into mass in 1 cubic decimeter of water. So 1 grams into 1000. This is 1000 grams. So this is mass in 1 cubic decimeter. So I need to convert this one into moles in 1000 cubic decimeters. Sorry, moles in 1 cubic decimeter. So that would be the concentration, right? So moles in 1 cubic decimeter of water. This is the concentration of water. So this is 1000 grams. This can be converted into moles by dividing it by molecular mass, that is 18 grams per mole. So this is in cubic decimeter, right? In 1 cubic decimeter. So this is answer is 55.556 moles per cubic decimeter. So this is a very, very large value in terms of the concentration. So concentration of water in water is 55.556 or something like that. So this is 500 divided by 9, no? 500 divided by 9 means 55.555, right? So this is how you deal with density and the concentration terms. Okay. Any questions on this one? Right. Number three, third question. Calculate concentration of H atoms in 100 cubic centimeters of in 100 cubic centimeters of water mixed with mixed with 0.365 grams of HCl. 0.365 grams of HCl. Chlorine is 35.5. Hydrogen is 1. මේක ආසන්න ගණක් මම ක්ලාස් එකේදී දීලා ඇති. හදන්න බෑ මේක ගන්න. බුදුසන්. I think I have given you some homeworks related to this one. මේක ගන්න හදන්නකෝ බලන්න. Right. Now here uh, we need to consider the um, the composition of the solution, right? So the composition is something like this. We have 100 cubic centimeters of H2O, and we have added HCl 0.365 grams. So this is the solution. We have been asked about what is the H or hydrogen atom concentration in the solution. Hydrogen atom concentration in the solution. So see, hydrogen atom, concentration of hydrogen atoms. Right? Now, if you closely look, H2O is a covalent compound. මේක ඉගෙන ගන්න දෙයක් තියෙනවා. මේ වගේ ප්‍රශ්නත් එක්ක තමයි මම මේ කියලා දෙන්නේ. හරිද? ඉගෙන ගන්න දේවල් තියෙනවා මේක. Now H2O is a covalent compound. Inside the solution, H2O will be as H2O. It will not be disassociated or it will not be converted into any other form. So H2O will be as H2O molecules. So H2O will not release hydrogen atoms to the medium. Because if you take water sample is consist of H2O. It is not consist of hydrogen atoms and oxygen atoms. It is consist of H2O molecules. Try to visualize what I am saying, what I am telling. So therefore, H2O is not producing hydrogen atoms to the medium. If you want to produce, you have to do the electrolysis. Then it will release H2 gas. අර පොඩි කාලේ කරන්නේ අර යෝගට් කප් එකකට ඉලෙක්ට්‍රෝඩ් දෙකක් දාලා කරන්ට් එක දාපුවාම from the cathode H2 will be released. Here no such thing is considered. H2O will be as it is. So H2O is not producing hydrogen atoms to the medium. Now let's take a look at on HCl. Right. So HCl, it's a covalent compound, but from your O-level knowledge, you know this is an acid. Right? HCl is an acid, hydrochloric acid. Acid means it is releasing H plus ions to the medium, and also it is releasing Cl minus ions as well. So in water, HCl will be converted into H plus ions and Cl minus ions because it is an acid. This is coming from your O-level knowledge. Make a බැරි වුණා කියලා මමතක නම් දැන් මතක් කරගමු. So HCl will be as H plus ions and Cl minus ions. HCl will be as H plus ions and Cl minus ions. So within the medium, what we can see is we have H2O, we have H plus ions, we have Cl minus ions. Sometimes there may be HCl which is not converted into H plus ions and Cl minus ions. Can be because HCl will not be 100% converted into H plus ions and Cl minus ions. That is the nature. So do we have hydrogen atoms in the solution? No. We don't have hydrogen atoms in the solution. Right? Because in summary, H2O will be as H2O molecules. HCl will be as H plus ions and Cl minus ions and HCl sometimes. H plus ions is not hydrogen atoms, right? H plus ions is H plus ions. It is ion. So therefore, concentration of each atom hydrogen atoms is 0 moles per cubic decimeter. There are no hydrogen atoms in the solution. These kind of questions are asking in MCQ. So any other term test or something like that. So you need to check from the chemistry point of view. Right? Right, next question. Number 4. 5.30 grams of 5.30 grams of sodium carbonate 5.30 grams of sodium carbonate is mixed in 500 cubic centimeters of water. 500 cubic centimeters of water. Number 1. First question. First part of that one. What is the concentration of this solution? Number 2. 200 cubic centimeters 200 cubic centimeters of water is further added to this solution. What is the concentration of the solution? Adhan ba? If you have done, you can send me the answers as well. No? If you want, I forget that one. Sodium is 23. Then we have done one. Carbon is 12. Oxygen is 16. Right. I will also do this one. Now, how it is produced or the prepared 5.30 grams of sodium carbonate is mixed in 500 cubic centimeters of water. We have been asked about the concentration in the initial solution. So this is, I'm taking out the first question. Sorry. What is the concentration of this solution? So we can find added or mixed moles of sodium carbonate. So you can say mass divided by molecular mass. Mass is 5.30 grams. Now molecular mass, molecular mass how much? 46, 12, okay,
106.
106. Okay, good. 106 moles per grams. So this is the moles, right? So this will be capillary, 0.05, right? So this is mixed within 500 cubic centimeters, right? So therefore, concentration of sodium carbonate. So this number of moles is within 500 cubic centimeters. I need to find how much within 1000 cubic centimeters. Simple logic. This is the concentration, right? Concentration means how much of moles will be there within 1 cubic decimeter. So this number of moles has been dissolved in 500 cubic centimeters. 1 cubic decimeter means 1000 cubic centimeters. So this is 0.1 moles per cubic decimeter. So this is the concentration when this is dissolved in 500 cubic centimeters. This is pretty straightforward. දැන් මේ කියන කතන්දරේ හොඳට අහගන්න ඕනේ. මේක දාගන්නකො. So the concentration of sodium carbonate in the initial mixture, when 500 cubic centimeters is mixed, that is 0.1 moles per cubic decimeter. හරිද? දැන් ඕම් පොඩි වැඩක් කරනවා මෙතන. ඔය වගේ ඒවා තමයි කෙමිස්ට්‍රි වලට එන්නේ. ගණන් වලට එන්නේ. හරිද? Now we have 500 cubic centimeters of water. Within this one, we have 0.05 moles of sodium carbonate. Now I'm adding water further. I'm adding water, 200 cubic centimeters of water. Now volume will be increased up to 700 cubic centimeters. But the number of moles will not be changed because we are adding water and we are not adding sodium carbonate. Sodium carbonate moles will not be changed in the initial mixture. So still the moles will be 0.05, right? Sodium carbonate. There is 0.05 moles of sodium carbonate and you are adding water into the same amount of moles. Yeah. Now the answer is correct, I think. Yeah. The answer correct. So the idea is here, water is added to the same number of moles. එතකොට කලින් කතන්දරය අමතක කරලා forget about the previous story. Now we have drawn the new story. Calculate the concentration for this one, right? So moles in 700 cubic centimeters of water, or you can say sodium carbonate moles. Still 0.05 moles. Moles is not changed. Therefore, concentration of sodium carbonate. This is 0.05 moles. This is within now 700 cubic centimeters. How much in 1000? So you can do the math for this one. I don't have the answer for this one. You can calculate. So this is moles per cubic decimeter. So remember, when you are adding water to a certain number of moles, concentration will be changed. Right? මේක අපි උත්තරේ ගමු බලන්න. මේකේ උත්තරේ මට මේකෙන් කියන්න දෙයක් තියෙනවා. This is 0.5 divided by 7, right? 0.5 divided by 7 means 0.07 0.071, right? So this is the new concentration after adding water. Now see, this is the yellow one, yellow circled one is the previous concentration, and blue circle one is the new concentration. So new concentration has been reduced because 0.1 is greater than 0.071 roughly. So which means addition of water is decreasing the concentration. ඒක මේ වගේ හිතන්න පුළුවන්. When you have cup of tea, now you have a certain amount of sugar. Let's say there is 100 cubic centimeters of cup of tea, and you have added certain moles of sugar, and you have some kind of sweetness within that 100 cubic centimeters. ඕකට තව වතුර add කරනවා. උණු වතුර ටිකක් හරි මොකක් හරි add කරනවා to enhance the volume or to increase the volume. Okay, ඊට පස්සේ බොනකොට the level high. That sweetness has been gone. That means the concentration of sugar has been reduced. Then ඔය සමහර වෙලාවලට දැන් සමහර කට්ටිය ඉන්නවනේ හොදි කන්න කැමති ඒ බත්වල. හරි. බත් එක්ක බත්වල හොදිනේ බත් එක්ක මොනවාරි හොද්දක් කන්න කැමති අය ඉන්නවනේ. මම හිතනවා අම්මට හිටි ගමන් මේ හොද්ද හිඳෙනවා. හොද්ද හිඳෙනවා කියලා එකක් වෙනවනේ උයනකොට. right? එතකොට මේ පොල් කිරි දාලා ඉතින් වෙන එකේ හොද්ද හිඳෙනවා. ඒක ගෙදර කට්ටිය වැඩි නම් අම්මා කරන්නේ හොද්ද වැඩි කරන්න ඕකට දානවා වතුර. එතකොට නිකන් හොද්දත් වතුර වගේ කොහොම හරි ගොඩ දාලා දෙනවා. හැබැයි රස ටිකක් අඩු වෙනවා. ඒ කියන්නේ concentration has been reduced. So best example is like that sweetness of a cup of tea. When you add certain amount of sugar and you make 100 cubic centimeters of cup of tea out of sugar, you taste it and there is some kind of sweetness. You add water without changing the sugar amount, then sweetness will be decreased. That means the concentration has been decreased, right? So here also it is obvious. It is given. It is proven by using our calculations as well, right? Ilangan. Next question, number 5, right? Hundred cubic centimeters of 100 cubic centimeters is taken out. 100 cubic centimeters is taken out from 0.01 moles per cubic decimeter NaCl solution. Is taken out from 0.01 moles per cubic decimeter NaCl solution. First question. Calculate number of moles of sodium chloride within 100 cubic centimeter sample. 100 cubic centimeter sample. Next one. Water is added until volume becomes 200 cubic centimeters. Calculate the concentration of new sample. Try then one. I will do this one, but give it a try. Hmm. Is this for the first one? Hmm. Okay. Yes. Okay. No. I'm asking for 100 cubic centimeters. I need 400 cubic centimeters. The first one you are taking out 100 cubic centimeters, right? හරි අපි මේ ගන්න හදමු. පුළුවන් කට්ටිය හදාගෙන යන්න තේරිච්ච අය. ලොජික් එකේ මේක ගන්න තියෙන්නේ. හරිද? හදාගන්න බැරුණා කියලා worry වෙන්න එපා. මම ඉගෙන ගන්න තමයි ඕන කරන්නේ. Now we have unknown amount of sample. The concentration is 0.01 moles per cubic decimeter. The idea of this one is if you take 1 cubic decimeter, there will be 0.01 moles of sodium chloride. That is the idea. Yeah, your answer is correct. Martila, yeah. So the concentration idea is within 1 cubic decimeter, or in other words, we should take 1000 cubic centimeters. It has 0.01 moles of sodium chloride. So what you do is you take out 100 cubic centimeters of this sample, and we have been asked about how much of moles of sodium chloride will be there in this sample. So this is our question. What has been asked? So we can simply say, for the first one, number of moles in 1 cubic decimeter, that is 0.01, or you can say number of sodium chloride moles. In 1 cubic decimeter is 0.01, right? That is the concentration. Make it only concentration, right? Therefore, NaCl moles in 100 cubic centimeters. So 0.01 moles is within 1000 cubic centimeters. 1 cubic decimeter is 1000 cubic centimeters. Then how much is in 100 cubic centimeters? Simple ratio. So this is 0.001 moles per cubic decimeter. 0.001 moles per cubic decimeter. This is the concentration of, sorry, the sodium moles within 100 cubic centimeters. මේ කවුරු හරි කෙනෙක් තේරෙච්ච නැති කෙනෙක් ඉන්නවද? මේක මාර important concept එක. This is number of not moles per cubic decimeter, moles, huh? Sorry. Moles නේ 0.001 moles. This is how much of moles in 100 cubic centimeters. ඊට පස්සේ අපිට කියනවා now we have this capital A, this yellow one, this one. Right? For into this one, water is added until the volume becomes 200 cubic centimeters. Now to this one, you are adding water until the total volume becomes 200 cubic centimeters, right? You are not changing number of moles. You are changing the volume. You are increasing the volume. So in NaCl for this one, within this one, we have calculated that is 0.001 moles. Now we have been asked, what is the concentration of this new sample? So pretty straightforward, this one. So if you take the second one, number of NaCl moles in 200 cubic centimeters. Same thing. Moles is not changed. So the concentration is how much within 1000 cubic centimeters. Therefore, NaCl concentration. So this 0.001 moles is within now 200 cubic centimeters. Okay, ප්‍රශ්නේ හොඳට කියවන්න ඕන. ප්‍රශ්නේ කියලා තියෙන්නේ water is added until volume becomes 200 cubic centimeters. So that means we have added excess 100 cubic centimeters until total volume becomes 200 cubic centimeters. Our interest is on the end volume, not how much has been added, right? So if this is within 200 cubic centimeters, how much is within 1000 cubic centimeters? That is the concentration. So this one is 0.005 moles per cubic decimeter. So this is the concentration of the second sample. ඔමලට තේරුණාද මේක? Understood. Okay. Concentration එකේ concept එකත් එක්ක අපි මේ play කරන්නේ. We are playing with the concentration concept. Right? කාට හරි ඕන නම් මිනිටක් දාලා ඉඳගෙන අදා ගන්න. For the concentration questions, visualization is a key. Visualization is a key. හරි. ඊළඟ number 6. How much of volume need to be taken? How much of volume need to be taken from 0.1 moles per cubic decimeter, 0.1 moles per cubic decimeter HNO3 bottle to make a sample of 0.02 moles of HNO3. How much of volume need to be taken from 0.1 moles per cubic decimeter HNO3 bottle to make a sample of 0.02 moles of HNO3? හරි බලාගන්නකො මේක ලොජික් එකකින් හදන්න පුළුවන් ඒක. තනිකර ලොජික් එකක් තියෙන. හරිද? ඔය එක ක්‍රම කියලා හිතාගන්න එපා. ලොජික් එකකින් හැමතිස්සෙම ගන්න. Here we have a bottle. In the bottle we have 0.1 moles per cubic decimeter HNO3. So the idea is if you take 1 cubic decimeter, there will be 0.1 moles. Now I need to take a kind of a sample, small sample. I don't know the volume, but I know it should have 0.02 moles of HNO3. This is the idea. I need to find this V. So the concentration gives me the idea. If you take 1 cubic decimeter, the moles will be 0.1 moles. Right? අපි එතනින් මේක අල්ලගමු. Number of, sorry, volume, අපි මේක concentration එක මේ විදිහට දාමු. Sorry. Number of moles in 1 cubic decimeter. That is 0.1 moles. So we can say number of moles in 1 cubic centimeter. අපි එහෙම නිකන් අපි සරලව එහෙම හිතමු නිකන්. So number of moles in 1 cubic centimeter ඔන්න එහෙම එකක් හදාගන්නත් පුළුවන් අපි. මේක නැතුව හදන්න බලමු. මේක පැටලෙනවා. හරි. Number of moles in 1 cubic decimeter. This is 0.1 moles, right? Therefore, volume required for 0.02 moles of HNO3. මේක එහෙනම logic එකක් තියෙන මෙතන. So 0.1 moles is within 1000 cubic centimeters. Then how much should I take in for 0.02 moles? Right. So that means if I take 1000 cubic centimeters, I have 0.1 moles. Then how much of volume is needed for 0.02 moles? That is the basic idea, right? So this is 100 cubic centimeters, not 100, 200 cubic centimeters, right? 200 cubic centimeters. Yes, 200 cubic centimeters means 200 milliliters. So if you take 200 milliliters, you have 0.02 moles. Our logic is number of moles in 1 cubic decimeter is 0.1. Then you can calculate how much of moles is required. That is, no, sorry, how much of moles is required is given. That is 0.02. So if the volume is 1 cubic decimeter, that is 0.1, then how much of volume is needed for 0.02? Just a ratio you have to consider. Right? So the volume required is 200 cubic centimeters. Number 7. Oh no. තව ගානක් හදමු. ටයිප් ගානක් කරමු. කොහොමද කියලා අහනවා. homework ටික හදාගෙන එන්න ඕනේ නේද? right. ටයිප් ගානක් කරමු. මේ වගේ. ඉදිමත නැහැ කට්ටිය. How much of volume need to be taken? Well, yeah. How much of volume need to be taken? How much of volume need to be taken from 0.05 moles per cubic decimeter HCl solution 0.05 moles per cubic decimeter HCl solution to make 1 into 10 to the power minus 3 moles HCl sample. 1 into 10 to the power minus 3 mole HCl sample. හරි. හදන්න බෑ. හදලා මට උත්තරේ එවන්න. You have to take the answers in the decimal places. So we can follow the same thing, right? Number of moles in 1 cubic decimeter. That is 0.05 moles. 0.05 moles. Therefore, volume required for 1 into 10 to the power minus 3 moles of HCl. So we can simply say in 1000 cubic centimeters, or in order to take 0.05 moles, you have to take 1000 cubic centimeters. Then how much of volume is needed for 1 into 10 to the power minus 3? moles. So this is simply 1 divided by 0 0.05. 1 divided by 0 0.05 means 100 divided by 5 cubic centimeters. So this is 20 cubic centimeters. Right? These kind of questions are very much needed for the related questions actually. Term test වලට මේ වගේ ප්‍රශ්න අහයි. මගේ paper වලත් මේවා ඉස්සරහට තියෙයි. So but අපි මේ ටික උරු වෙන්නේ for the complex questions. Right? So what you need to do is you have to understand the concentration logic, the idea of the concentration. Then after that you can play around the concentration. Right? මේක තව එක තව විවිධාකාරයේ විදි තියෙනවා ගණන් අපි හදමු ටික ටික. So මේ සතියේ පේපර් එක තියෙනවා 12 කාලට ඇවිල්ලා හැමෝම ලියන්නේ MCQ එකක් තියෙන්නේ 12 කාලට ඇවිල්ලා ලියන්නේ MCQ 20ක් විතර වගේ තියෙයි 20ක් විතර වගේ තියෙයි මිනිහට at least පාක් මන් දෙන්න ඇවිල්ලා ලියන්න ඒක මම ඩිස්කස් කරනවා බ්‍රාස් වෙන්න සිකුරාදා chemical calculations and chemical bonds තව අපිට තව ටික එකතු වෙනවා ඒවා ගණන් මම හදාගෙන යනවා ඒකට ගොඩක් වෙලාවට අපේ schedule එක වෙන්නේ Thursday paper discussion, Friday mix exercises. අපි ගණන් හදනවා. මේක මම මේ දැන් පැයක් කරාට ඉස්සරහට තව මේකම වැඩි කරනවා. තාම ඔයාලට ලොකුවට මානසික කරන්න ඕනේ නැති නිසා මම මේ ටික කරා. ඉස්සරහට ඒක අපි ටික වැඩි කරලා පැය දෙකක් විතර වගේ ඉස්සරහට ගමු. පැය දෙකමාරක් තුනක් විතර වගේ බලන්න ඕනේ. right. හරියම අපි ක්ලාස් එක විතර නතර කරමු. Let's meet on Sunday. Good night and we'll talk about Sunday.